visitor. NASA had promised some sharp images and delivered some blurred out shadows. Now, the netizens want to know what is the 3-eye atlas and what exactly is NASA trying to hide here.
That night began with a moment that broke every familiar rule, because the object everyone believed was a comet returned as a perfect green sphere after passing behind the sun. Its smooth and steady shape confused observers since it did not match any natural pattern we normally see in space. This sudden change forced NASA, major observatories, and even the United States Department of Defense to pay attention because no one had a clear answer. The transformation appeared too clean and too controlled to ignore. What really happened during the hidden hours when the object slipped out of sight? The first confirmed evidence came not from large observatories, but from ordinary people who spent their nights under open skies, because amateur astronomers were the ones who caught the strange sphere before any agency reacted. A man in Wales captured the first clear image just after midnight when he stacked multiple exposures into one sharp frame that showed a smooth green orb with no tail and no haze. The picture looked unusual, yet it was so clean that it quickly spread through online forums where other observers compared their own results. Within hours, similar images appeared from Toronto, Osaka, and Madrid, and each one showed the same bright circle with no signs of dust or debris. The consistency surprised many people since these observers used different telescopes and different sensors, yet they recorded the same shape with almost identical brightness. The growing interest pushed amateurs to check their equipment carefully so the details could not be blamed on poor calibration. Many observers shared their original FITS files to let others test noise levels and exposure patterns because the color looked almost too vivid to be real. However, repeated checks showed that the green tone stayed the same no matter which filter or lens was used. Some used small reflectors while others relied on advanced CCD rigs, but the object never blurred or stretched across the frame even during long exposures. This stability made the situation even more unusual since real comets always show motion or fragmentation at the edges when the camera collects light over several seconds. Forum moderators highlighted a clear image from a school observatory in Maine that revealed a perfect circle with uniform brightness from every direction. The brightness varied by only 3% across the surface, which is extremely rare for any natural object moving that fast. The absence of dust was also important because a comet that recently passed close to the Sun should show bright jets and a long trail of particles. Instead, the sphere kept the same structure for more than 20 minutes while observers collected frame after frame. If the shape had been caused by a camera error, the outline would have shifted during the sequence, yet every shot matched the others with surprising precision. As the images continued to appear online, professional observatories quietly checked their own data from the same time window. Many confirmed that the shape seen by amateurs matched their initial observations, although most institutions waited to release formal statements. The amateur community effectively recorded the transformation before any official branch could shape a narrative, and their records became the first independent timeline of the event. This early documentation now plays an important role because it shows that the change did not come from image processing or scientific assumptions. It came from direct observation made by people who trusted their equipment and shared every raw file for public review. This leaves an important question for everyone watching the case unfold. If amateurs were the first to see the strange sphere, then what did the professional observatories detect before the transformation became public? The earlier images from July and August showed a completely different object because every observation matched the behavior of a normal comet that was entering the inner solar system for the first time. Hubble captured a glowing nucleus wrapped inside a wide coma, and the photographs revealed long streams of dust pulled away by sunlight as the object moved closer to the sun. This pattern fit everything scientists expect from an icy body heating up in space, and the brightness curve followed the same rise seen in many other comets. Even at that early stage, smaller details such as faint jets and fragments were visible, and these features confirmed that the object reacted to solar radiation in a way that looked familiar. The Stereo spacecraft collected its own measurements during this same period, and its data described a classic teardrop shape with gas boiling off the surface at high speed. These details match the independent notes recorded by amateur observers who tracked the object from their backyards at night. Their photographs showed a tail stretching thousands of miles behind the core, and the glow looked uneven in the way dust clouds usually appear when pushed by solar wind. The color also stayed consistent with ordinary comets because the chemical reactions around the coma often create a temporary green tint that appears stronger during certain angles of sunlight. The combined reports created a clear baseline that left little room for doubt, and scientists used these early images to build models of how the comet should behave as it approached perihelion. Since many comets show their most dramatic changes near this point, researchers expected brighter jets, a thicker coma, and more fragments drifting into space. Observations from July and August supported these predictions because the jets looked active and the motion of the dust suggested strong outgassing. Everything about the object seemed to follow textbook physics, and the early measurements fit the orbital calculations with remarkable precision. The sense of normalcy grew as professional and amateur images continued to match each other, and this agreement strengthened confidence in the initial classification. The object moved across the sky exactly where the math predicted it would be, and the coma expanded in size as the heat of the sun reached deeper layers of ice. Such details usually indicate a stable comet that is losing material in a regular pattern, and nothing from the early months suggested it would behave in a strange way later on. The smooth overlap between multiple sources gave astronomers a reference point they could trust, especially because the data remained consistent across different instruments and exposure settings. This stable beginning makes the later transformation even more dramatic because the shift did not follow any slow transition or gradual fade. Instead, the object changed appearance in a way that felt sudden and complete, which forced many experts to question what could cause such a sharp break from its original state. If the comet looked normal in every way only a few months earlier, then how could it lose all of its expected features so quickly after passing behind the sun? The transformation after perihelion became the turning point of the entire mystery because the object no longer showed any of the features that had defined it for months. A comet that passed close to the sun should release more gas and dust as the heat breaks apart the surface, and this reaction normally creates bright jets and long tails. However, when the object emerged from behind the sun, observers found that the entire structure had changed into a smooth sphere with no signs of activity. This sudden shift confused researchers because the change did not follow any natural pattern that has been documented in previous comet studies. Instead of becoming brighter and more chaotic, the object became cleaner and more uniform. Images taken from multiple locations supported this conclusion because each frame showed the same smooth outline. This consistency removed any possibility of camera errors or unusual angles. If the comet had broken apart during its closest approach, then dust clouds, splinter trails, or fragments would have appeared in the photographs, yet nothing showed up around the sphere. There was no haze around the edges and no faint streaks drifting away from the core. The lack of any debris became one of the most surprising details since fragmentation is common for comets that pass near the sun. Even small particles should have appeared in long exposure images, but the sphere remained alone in every shot. observers also examined the brightness pattern to search for hidden disruptions that might reveal cracks or uneven surfaces. Instead of irregular patches, they found a surface glow that stayed balanced from one side to the other, and the brightness varied by only a tiny percentage. This level of uniformity is extremely rare in nature, especially for an object that just experienced intense solar heating. Researchers expected the nucleus to show signs of stress, but the sphere looked untouched. Some astronomers compared the shift to a shell forming around the core, although no scientific model explains how such a structure could appear so quickly. Regardless of the theory, the change felt too clean and too complete for a natural reaction. The absence of jets became another key problem, because jets are usually the main source of force for any non-gravitational movement. Without them, the comet should have followed a predictable path based on gravity alone, yet the recorded trajectory continued to drift. This mismatch between motion and appearance pushed many researchers to reconsider what they thought they knew about the object. If the sphere was not losing material, then what caused the change in direction? The question became more pressing as astronomers realized that the shift happened at the exact moment when the sun blocked almost all visual tracking. This brings the story to the next challenge that scientists faced as they tried to understand the object's new behavior. When the transformation happened behind the sun, what data was captured by the spacecraft that had a chance to see it during that hidden window? The hidden journey of the Mars Reconnaissance Orbiter became one of the most sensitive parts of the investigation because the spacecraft captured the closest images of the object during the period when no one on Earth could see it. HiRISE, the main camera on the orbiter, was designed for detailed views of the Martian surface, yet its extreme resolution made it capable of catching a brief snapshot of the fast-moving object. The team prepared the shot on October 1st, and the single 3-second exposure was taken just hours after the government shutdown orders reached NASA. This timing made the situation complicated because every file, request, and transfer needed extra authorization, which slowed the release of scientific material. The captured images were transmitted to the Jet Propulsion Laboratory and the University of Arizona, and they were stored as compressed data in the mission archives. Although the images reached both institutions by October 4th, they did not appear in any public channel, and NASA's usual update cycle became strangely quiet. Some researchers suggested that the shutdown created a backlog that delayed the processing steps, while others pointed out that the files had already passed the initial checks. This raised questions about why a simple data release was taking weeks instead of days, especially when other missions had no trouble sharing their own results. As the silence continued, the contrast between different space agencies became impossible to ignore. China's Tianwen-1 probe completed its Mars flyby and released its own images of the object within 2 weeks. Their photographs were quickly studied by independent analysts, which only increased pressure on NASA to respond. Lawmakers began to take interest as the reports spread, and Congresswoman Anna Paulina Luna formally demanded an explanation for the 6-week blackout on the HiRISE files. Her letter pointed out that the scientific community and thousands of amateur observers had already documented the object's transformation, so there was no reason for NASA to hold the highest resolution images in storage. The pressure led to a closed-door meeting between NASA officials and select members of Congress. The agency promised that the images would be published once the object cleared solar conjunction, but they refused to discuss what the raw data showed or why the internal review process had stalled. When the images finally appeared on November 19th and 20th, they were released as processed files with detailed notes about calibration methods. However, NASA did not share the uncompressed FITS data, telemetry logs, or chain of custody records. These missing details made some experts question whether important information was still being withheld. Despite the controversy, the published images delivered a clear view of the object and showed a smooth sphere with no jets or fragments. The photographs supported the same features reported by amateurs, yet the circumstances surrounding the delayed release created new doubts. If the data was ready in early October, then why did NASA wait until mid-November to share the images with the public? This leads to the next issue in the story, which raised even greater concerns among astronomers. If the closest images offered no explanation for the object's behavior, then what did the orbital data reveal about the forces pushing it across the solar system? The orbital data revealed one of the most important clues in this investigation because the object did not follow the path predicted by gravity alone. Astronomers used more than 1,000 precise measurements collected by Hubble, the Mars Reconnaissance Orbiter, ALMA, and the Stereo spacecraft, and each data point included exact coordinates, timestamps, and instrument codes. When these numbers were added to the Minor Planet Center database, researchers plotted the expected path and compared it with the observed one. At first, the two matched closely, yet the difference began to grow as weeks passed. The residuals drifted gently at the beginning, then reached a full arcsecond and later increased even more. This steady shift showed that something was pulling or pushing the object in a way that gravity could not explain. Specialists at the Jet Propulsion Laboratory used the Horizon system to process the data, and they found that a non-gravitational acceleration appeared in every model. The parameter known as A2 refused to drop to zero, even when the system was adjusted with different error margins. Harvard ran its own analysis with separate methods, and they reached the same result. This agreement suggested that the force acting on the object was not an error or a mistake in the calculation. Instead, it was a persistent influence that remained strong for months. The numbers showed that the direction of the push pointed slightly toward the sun and continued even when the object rotated, which confused researchers because such a pattern usually comes from jets shooting out of the surface. The problem was that every image taken after perihelion showed a smooth sphere with no jets and no fragments. For a comet to change its orbit in this way, it must lose a significant amount of mass. Harvard's team estimated that at least 10% of the object's total mass would need to escape into space to generate such acceleration. This type of outgassing produces long dust streams or bright patches around the core, yet none of those signs appeared in the high-resolution images. Even small particles should have been visible, but the area around the object stayed completely clear. The contrast between the images and the orbital data became one of the biggest contradictions in the case. Researchers tried to find explanations within accepted physics, but none of the usual theories fit the situation. Solar pressure could not create the pattern seen in the numbers because the force was too weak. Fragmentation would leave a cloud of debris that telescopes would easily detect. Gas vents would point in different directions as the object spun, but the recorded push remained steady. All these details suggested that the object moved as if guided by a controlled force, although no visible source existed. This idea remains controversial, yet the data repeatedly points to a mechanism that hides from every instrument aimed at it. This leads to another question that many astronomers began asking as the analysis continued. If the object experienced a force that could not be seen, then how could its strange path become even more unlikely when compared to millions of simulated trajectories? The statistical models created by scientists became one of the clearest warnings that the object's movement did not follow the behavior expected from a natural comet, because the numbers revealed a level of precision that was extremely rare in random space motion. Harvard researchers built 100,000 simulated trajectories using the object's early orbital data, and each simulation tested how a typical interstellar body would travel if it had entered the solar system at the same angle and speed. Most of these virtual paths curved away from the ecliptic or passed through the system at unpredictable inclinations. Only 5 simulations produced a path that matched the real one, and these 5 required conditions that almost never appear in nature. This result suggested that the object's flight path resembled a selected route rather than an accidental one. The European Space Agency repeated the experiment with their own dataset and reached a similar conclusion. Their model estimated that the chance of the object passing Mars, Venus, and Jupiter at the exact distances recorded was roughly 0.006%. This probability was so small that many astronomers described it as mathematically unnatural. A comet influenced only by gravity should drift slightly as it sheds ice and dust, yet the object moved with a steady precision that surprised the scientific community. Its smooth curve through the solar system looked more like a path designed to avoid unnecessary energy loss than a direction shaped by melting material. Timing also played a major role in the mystery because the object crossed behind the Sun at the exact moment when almost every Earth-based telescope was unable to observe it. A natural comet would pass through the hidden zone at many possible angles, but this object entered and exited the blackout period with perfect alignment to the period when direct monitoring was impossible. This created a blank space in the observational record, and that gap matched the moment when the object's shape changed into a smooth sphere. The overlap between these events made the situation harder to write off as coincidence. Another unusual element came from the way the flight path placed the object within viewing range of several active spacecraft. Although this alignment could still occur naturally, it added another layer of intrigue because most comets move along wide arcs that do not match spacecraft positions with such accuracy. The alignment suggested a path that remained visible to robotic observers while avoiding long periods of direct human observation. Analysts debated whether this pattern was intentional, but the numbers repeatedly showed a movement that seemed optimized rather than chaotic. These combined findings raised an important question that many researchers began discussing openly. If the flight path was so unlikely, then why did it seem to follow a sequence that matched the most controlled windows for observation and disappearance? And most importantly, what kind of force or planning could create an orbit that nature almost never produces? Government involvement grew more intense as the object continued to behave in ways that scientists could not easily explain, and each agency's reaction created a chain of events that raised even more doubts. The Pentagon's all-domain anomaly. Resolution Office placed the object on its watch list in July after astronomers confirmed that it came from outside the solar system, and this decision showed that national security officials believed the situation required special attention. Internal activity increased quickly because logs described sudden data sharing requests and a rise in classified communication, which suggested that the object was not being treated like a simple comet. These early reactions made researchers wonder if officials saw signs that the public had not yet heard about. The confusion began when the Pentagon changed its position in mid-November and stated that the object did not fall under the office's mission. This unexpected reversal created a sense of uncertainty because no one explained why an interstellar object had been considered a potential concern only to be dismissed later. A natural comet has never appeared on a national security list, which made the downgrade feel even more unusual. NASA also avoided discussing what information they had shared with the Pentagon, and their silence made many viewers believe that the agencies were withholding important details. At the same time, Harvard professor Avi Loeb released a list of 12 anomalies that did not match known comet behavior. His summary included the unexplained acceleration, the smooth sphere shape, and the object's stable path without visible jets. He explained that all these features were testable and should be examined through targeted observations in December. His list spread quickly through astronomy communities because each anomaly was supported by observed data rather than speculation. Many younger scientists agreed that the situation deserved open research instead of quiet dismissal. Rumors then added another layer of mystery when amateur astronomers claimed that several glowing spheres were moving near the main object. These stories appeared on message boards, but none of them included timestamped data or verified image files. Some posts claimed that the spheres stayed aligned with the object at the same speed, yet professional observatories did not confirm any of these sightings. The only real chance for verification will come when ESA JUICE spacecraft sends its data back in February, and until then, the idea of companion objects remains unproven. NASA's communication style also shaped public opinion because they released statements that avoided strong conclusions. Their careful language did not answer the central questions about the blackout period, the delayed images, or the missing raw files. This lack of clarity strengthened the belief that officials were trying to manage the story rather than fully explain it. When all these reactions are viewed together, a difficult question appears. If every agency insists the object is natural, then why does their behavior suggest that the situation is far more unusual than they want to admit? The countdown to December 19th has become the moment everyone is waiting for, because this will be the first time every major observatory can watch the object without any blackout. Scientists expect that any change in its direction, brightness, or speed will appear clearly, and this makes the event one of the most important tests of its true nature. The world will finally see whether it behaves like a comet or something far more intentional. What do you think we will discover when the sky opens again? Share your thoughts below and remember to like, follow, and subscribe for the next update.